now going to touch the pad. Everybody in the world fused. Yeah. Morning crew, and welcome back to the Andy Mechanic YouTube channel, and this is the start of day 3 of a 10-day stint of putting all the steelwork, well most of the steelwork, in the workshop so we can get rid of this retaining wall. So if you've watched the previous videos, there was 2 or 3 that covered sort of the design, and then there was yesterday's video which went out this morning because I stayed up very late last night editing it for you. Basically covering the testing of the UB14 I-beams when they're in the horizontal configuration with no modifications, just one long beam essentially covering a span of 5.7 meters. And if you watch that video, you'll see how much that beam deflects when it's under the load of what I expect to be 25% of this roof, because there's 4 beams, so obviously the weight's shared out across the 4. Now, the beams won't be straight when they're installed. They're going to have an angle to them because we've got, an angle on the lean-to roof, which is that workshop over there, and here we're going to replicate the same angle. So here is my very technical drawing, and you can see here, look, the beam is in 2 pieces. You saw on the previous video there was a join, and we need to work out what this angle is. I have no idea, but we need to know so we can replicate it with the steel. So, in readiness for this video, a while ago, last week actually, I purchased, no, this week, it's still only Sunday, so on Thursday I picked up one of these, and this is a what they call an angle finder over here, and you can basically just keep moving that around and it'll tell you what angle it's at, which is pretty cool. So if you go back down to there, it should go to 0, hopefully, I don't know, near enough. You can zeroize it. There's a little 0 button somewhere around there, and it'll go all the way out. You can take off the little clamp here, look, and it'll go all the way round. So you can do all sorts of angles with it, which should be really, really useful. So now that I've got this, and it wasn't cheap, and if any of you have used this brand before, got any experience of the quality and that kind of stuff, or any known problems with one of these, and this is, has it got a code on it? That's the only code it's got. Don't know. Doesn't look like a... Anyway, so if you've got any problems or had any experience with this, yeah, look, Pro Digital T bevel, then let me know, because I only bought it a couple of days ago. Okay, right, so what I did is on the lean-to side, which is going to set the angle, I have installed a bit of angle iron and set it to level using a long spirit level. Took quite some time, getting that bang on. And now we can use this between our datum, which is the horizontal, and the angle of the beam, and that will give me the angle that I need to then be able to do the various cuts on the I-beam to match that angle. I'll show you what I've done. Here we go. Okay, so she's nice and level, that's perfect. And now we get our little angle finder, and that should fit in there, hopefully. There we go. And we can just open up the little arm. And we've got an angle of 4.15, so 4.1 degrees will do the trick, I reckon. Perfect. Good job. Hopefully you can see the screen. Well, what a nifty little tool that is. About $180 odd that cost me. Now I know you can buy really cheap ones from places like Mitre 10 and Bunnings here in New Zealand, but I don't like buying cheap tools, So anyway, you're probably going to see a lot more of this as things move along. I was told that when it gets to 45 degrees, it does a beep. I think. I don't know. Just think of memory. So let's see if we can get 45 degrees out of this. Here we go. Let's see if it's going to beep for you. Maybe you've got to change the settings. I don't know. Nearly there. Can you see that? Oh, you can now. pretty accurate the way it works. Yeah, 45, is it going to beep? Nope, it's silent. God damn. And there was no instructions with it other than what was on the actual box, so I have to have a play around with it, won't I? Okay. Oh well, we'll turn that off. There we go. Go to sleep now. Save the batteries. Okay, well, I've got a long day ahead of me again. I don't know, I'm going to bring you along at certain points during the day. This was one important point. Needed to work out the angle. 4.1 degrees. Now I can measure, I can do some marking up on those I-beams and do some cutting and some more welding and stuff. So once that's done, and there'll be a few little shots, I'm sure, between now and the I-beams being finished. And if I come across any problems, I'll bring you back on board for some help. And then at the end of the day, if all goes to plan, we can test the new shape I-beam, load test it, and we can measure the deflection again. Sounds like a plan? Okay, well, have fun. I'll see you later on. Right, trying to get this 4.1 degree angle. Oh, almost 4.05. Jeez. A little bit more on the ratchet strap, see where we end up. Oh, there we are, look. Nope. Oh, there we go. Yep, 4.1. Fantastic. I'll get that tacked up. So I had to come up with a way of clamping the angle accurately. So I made, around here, look. I made a little jig that I can clamp onto the girder. That jig is set exactly 4.1 degrees of angle. I can cut the notch out of the beam. And then I can line everything up, and I've left the beam slightly attached, just in there, look. And that way I can just tack weld that with complete confidence that it's not going to move anywhere and that it's bang on. Took me a while to work that one out. Jeez. Right, I'm back, and my apologies, I haven't done that much filming today. Sorry. I'm never very good at doing filming when I'm doing fabrication work, but I have got a lot done. Not quite as much as I'd hoped, but I have made some plates for the second beam as well while I've been on. Let me take you over to the bench behind me, and I'll show you what I've done so far. Here we go. Right, forgive the handycam stuff going on, but we'll start down this end. And I really wanted to make sure I got these angles right. So we've got 4.2 degrees. Sorry, 4.1 degrees on each of those two joints, and I've put the spreader plates on and it's all welded up. Still needs cleaning up, there's a bit of splatter on there. I don't quite know why the MIG's splattering so much today, but anyway, not to worry. And of course it's got spreader plates on the far side as well. Great stuff. So I'm quite happy with that. Definitely think it's going to be strong enough. And we'll head down here to the other end of the main lean-to beam. I won't touch it because it's still really hot. But all that's, where's my pliers? Hang on. I've just got to make some minor adjustments to that because it's slightly the wrong angle. But that's all welded up into place. So I've just got to weld tomorrow. Once I've made the final adjustments to get the angle of this 4.1 degrees again, then I can weld that into place. All the holes are drilled. And the other plates that I've made are just over here, look. My trick, when we've got a matching pair of plates that are going to go together, is just to tack weld them together while I'm drilling them. And that guarantees you're going to get all the holes in the right place. So that's enough there for this, finish this beam off, and the foot plates for the other beam as well. Jeez, it really doesn't look a lot, does it? But believe me, it's quite a lot of work. It's pretty heavy, that's the problem. Right, back to the bench. Okay, well, it's about 6:30 in the evening now. I've been told tea is almost ready, and I've got to tidy the whole workshop up again. I came outside this morning about 7:30, so it was pretty early on. Got lots done, but not quite as much as I'd hoped. Anyway, tomorrow morning I can get that beam finished, get the foot, which I've already made actually. So I've made a little piece to go on the end of the other beam. That's all angled and ready to go. Again, it'll probably need a minor adjustment before I weld it into place. And then the other beam will be good to go. So by about lunchtime, I reckon tomorrow, we'll be able to do the load testing of the final design. And again, we're going to put 250 kilograms in the, on the coffee table. It really is a coffee table, honestly. And we'll be able to measure the deflection and see if it's any different. Hopefully it's going to be a bit less, but it shouldn't be any more. Fingers crossed. Anyway, it's time for me to sign off. It's been a great day. Sorry you've not been with me quite so much. I'll try and do more filming tomorrow. Of course, we'll be filming the load testing side of it. And then, if it passes, I can film the installation of the first beam. Whee! Okay, crew. See you later on. Quick flyby. Here we go. I don't really know what that was. It was just a bit of fun, really. Right, it is the start of day 4. Day 4. I'm going to run out of fingers on this one. It's about 20 past 8. I came out about 7:30. Takes ages to get all the workshop cleared out and get ready. But now we get the chance to set that last foot. Now it's cooled down a bit now, so you can see basically the underside, and of course I've got to weld this onto the beam. But the angle is slightly out, so we're going to measure the angle, and then I'm going to have to grind a bit off this end and readjust or grind down. This middle bit isn't that critical, to be honest, because it's going to fill with weld anyway, and having a bit of a gap is a good thing. It helps the weld to penetrate and do its job. You're supposed to have a bit of a gap between plates. So yeah, up. It is up, and that's going to be well, in fact, actually, as the garage is, it's going to be that way around. So the beam sits on top of here, and it's pretty damn critical that I get the angle right. And I mean, at the end of the day, the plate that this one bolts to, which is going to be welded to the beam, I can bolt to this first before I weld it to the beam, and then that way we know it's going to be seated at least. It may not be absolutely dead flat, horizontal, it should be, but we're going to set this one to 4.1 degrees, which is, almost, you can see the beams behind, look. It's basically the angle of those beams, and you saw that earlier on in the video. So without too much waffle, I do want to try and carry you along on this journey. I know that these videos of doing this beam work aren't everybody's cup of tea. The videos don't get very many views, but it is all part of the Andy Mechanic journey, and it's a significant chunk of work. It's probably one of the biggest projects that I've ever done, certainly on the channel anyway. So there we go, bit of grinding. Let's get the angle set. Remember, 4.1 degrees is the magic number. That's what we're chasing. Here we go. Right, everything to camera, Andy. Do it all to camera. Okay, so we'll turn that on. Make sure we're on 0. Are we on 0? Yeah, I think we are actually. It's pretty good. Okay, so let's just see what this is going to give us. Got to make sure that the pivot's in the right place. Okay, so at the moment, if we get the 180, we're at 4.6 degrees, and it needs to be a little bit less. That needs to come up slightly to 4.1, so you can see there's hardly any difference. Almost just a millimeter maybe will give us the 4.1 that we need. So I need to trim this end down by a millimeter off the end of there. So it's time for a bit of grinding, I think. Right, let's crack on. Okay, so we've got to come down a bit on there. Looks like about a millimeter. So we'll have to wait and see. Sort of trial and error, really. Let's give that a go. A lot easier to do lots of little bits than overcook it. Jeez. Okay, here goes. Now, I think we were 4.6 last time, weren't we? Now, what's also important, and I have to keep playing around with it, is this is about level with that ridge, otherwise it's going to throw it out, but it's bloody close. Just going to make sure that one's off there. Oh, there we go, look. Right. No air gaps anywhere. Okay, so we've come down a fraction. A bit more yet. Jeez. Right, give that a go. Trying to be as accurate as possible with this, because it's only going to bite me later on if I'm not. Right. Okay, we've got a bit of a step there now, so we're going to need to pull that ruler out. I did get some cardboard just to try and shim it, because it's important we keep that level, the two parts level, otherwise it's going to give us a false reading. Good old Worth. Right, nice calendars by the way, lads. Where's my 2019 one? Okay, that's pretty good. Right, let's see where we're at. Fingers crossed. Oh, so close. Now, let's just check for air gaps. Use my torch. Okay, well, it's sat pretty good on there. Of course, that plate's a little bit dish because of the welding. Okay. Fraction more. Here goes. Still pretty good. Oh! Beep, 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 beep. Beep, 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 beep. Bang on. That's what we wanted, wasn't it? 4.1 degrees. You can see that on the camera, that bit of glare on there. There you go. Perfect. I can weld that on now. Now, I did slightly overcook it earlier on, off camera. So I just welded a couple of little blobs on there and then filed them down until we got to the right height. Pretty nifty, eh? Okay, so the next job, before I can weld this on, is I have to put bevels, 45-degree angles, on every part that's going to be welded. So all the way down here, 45 degrees around the ends, so the weld can penetrate right in and we can get a nice deep weld, because don't forget, these things are under a lot of stress. I mean, sure, it's a compression force on this, but it's still be welded on properly, hasn't it? So I'll get those bevels ground, and then we'll get it we'll double check the angle after we've welded the, done the grinding, just to be on the safe side, and then we'll tack it into place, double check it again. It's all about checking, isn't it, with this kind of stuff, and then weld it on. Here we go. Right, let's check it again. Jeez. Fingers crossed, this is a nightmare. Oh, there we go. Perfect. I obviously got up way too early this morning and completely forgot about the jig that I'd made yesterday for doing the angles at the other end of the beam. So I've set it up, you can just see it there, look. So I'll give you a close-up and then we'll get it welded into place. Now, yesterday I'd made this jig, and this is made of some pretty hefty, I think it's 10 or 12 mil plates, 12 mil plate probably, and it's got a couple of feet on it, and this gives us exactly 4.1 degrees between the two plates, and that's exactly what we're looking for. So hey, why not use it, to be honest? So I've mounted it up on some hefty box section, probably about 5 mil wall, on top of the beam with some very thin packers, just to give us, when it's all clamped up, a tiny, tiny air gap between the foot and the beam, so we're absolutely certain that we're sat. Yeah, look, you can see the air gap on there. It's not easy with the clamps in the way, but yeah, there's an air gap all the way across. And that means that the foot, is in exactly the right position. So I'm very happy with that. I've lined up all the sides. These are all true now. So I can tack that into place with full confidence that it's at the right angle. Geez, forgive the crappy camera work today. The important thing is I'm getting on with the beam and I'm bringing you along on the journey. So I'm going to go and grab my bacon butty that I've just been called for. It's all ready. It's great to have a resident cook, isn't it? And no, she's not a tool girl. Sorry. So I'm going to head inside, have the bacon butty, come back outside, and then we'll tack weld that in place, remove all the paraphernalia, the brackets and the clamps and everything, and then get it welded into place proper. And then that beam is finished. And all I have to do then is weld the other foot at the other end of the other beam. And now that I've got a system in place that I know is going to work really well, I can just replicate the same and it shouldn't take too long. I'll see you after my breakfast. Cheers. Just never ends. Right, we need those next time. Right, we can get that welded on proper now, can't we? Jeez, but we don't get any splatter on the lens. God. Done. Okay, quick flyby before the cleanup duties. I reckon that'll work, don't you? Look at the splatter! God damn. Okay, round to the side, because you'll all ask what the other side's like as well. It's not too, the splatter's not too bad. It'll clean up, that's what all that matters, isn't it? Okay, time to crack on. Geez, it's now 10:45 and I had about 15 minutes break for a bacon butty, so it's taken me, including the filming, 2 hours to get that foot aligned, ground a bit, you know, manipulated, clamped, welded, and all that kind of stuff. 2 more hours gone. That's ridiculous. It's going to be another long day. Okay, time to move that, well, clean up and then move that beam and then put the foot on the other beam and then I can start testing it. Woohoo! At last, I'm back. The second beam is finished. We'll take a quick look, then I'll get it all rigged up for the testing. Here we go. Okay, the second foot is in position. It was much quicker now that I've got that, where is it? I don't know, that thing. My little test rig, not test rig, my jig, that's what it is. And there you go. It hasn't been cleaned up yet. You have no idea what I had to do to set this rig up all on my own. This thing is getting bloody heavy. There you go. It's pretty safe. It's on the infamous oil drums. Hopefully they won't collapse. Right, what do you reckon? Is it going to deflect as much? Where's Lily? What do you reckon, Lily? Is it going to deflect as much as the standard horizontal beam, or, given the shape, is it going to manage to deflect less? Only one way to find out. Right said Fred, here we go. Get the old crane scale put on. Don't drop the crane scale, Mr. Young. Whatever you do. That needs to go through there first. It's been a good little tool, this crane scale, actually. Okay, centre point of the beam, 5.7 metres span. A bit more room underneath now, so the bricks are going to hang a bit higher. That's why I put the plates on the end of the beam. It's pretty sturdy. Look at that. Jeez, we are so close. Sorry, Tang. Cool. That's not going to move anywhere. So that's going to give us a really good datum now to measure from. Geez, here we go. Right, so I want to get a datum without the weight of the basket on there, sorry, the coffee table. Just take the weight off it and get a little measuring device. See where we're at. Okay, so we've got 334 millimeters gap. So without the basket, I know there's a 3mm deflection when it's under its own weight. I measured that earlier on. So we've got 3, 3, 4. That's just the beam. Oh, sorry, that's the wrong one, isn't it? So 3, 3, 4 goes in there. God, messed up my chart already, haven't I? Okay, now we're going to hang the basket, the coffee table, and we'll take another reading. Now, we know the coffee table weighs 32.5 kgs. We measured that last time, so no need to worry about the crane scale at the moment. So, next reading is... Ooh. Excellent. 3, 3, 4 again, which means it hasn't moved. No need to cross it out really, was there? So 3, 3, 4, and of course we've still only got 3 millimeters of deflection. Okay, 20 kgs of bricks coming up. Should be about 10 bricks at my reckoning. I wonder if all the wildlife's gone out of these bricks yet. Man, there were some big ass spiders in there. Okay, that's 4. We'll do 5 there. You've got to try and keep this thing balanced at the start. It's really tippy. 12 kgs. That should be 20. Perfect. Okay, here goes. 335. We've moved 1 millimeter. Damn. Okay, so 20 kgs. We got 3, 3, 5. That's one more, so we're 4 millimeters of deflection now. Right, more bricks. Dum dum dum. Deja vu, this, isn't it? Groundhog Day, more like. we there? Jeez. Okay. 41 kilograms. Right. What do we got this time? 338? What the hell? Let's try that again. Well, that's what it says. Things have moved. Holy shit. Right, 41 kilograms. 338. Holy moly, I wasn't expecting that. So we've gone up by 3. So we're now on 7 millimeters of deflection. That's more than half of the total we had last time. Oh, things are not looking good for my new beam, are they? Right, 60 kgs coming up. .5. That'll do. Jeez, I hope I haven't moved again. The same. It's settled down. Wonderful. Okay, 61.5. We're at 338 still. It still gives us 7 millimeters of deflection. More bricks. Oh, we need some on this side now. Spins around nice and easy. .5, 72. 76, nearly there. One more. 80, perfect. .336. That's not right. What the hell? Let's try that again. .337. Well, there's no way it could be less. .336. I think some of our results are wrong. Damn Ryobi, honestly. So I'm going to take 40 kgs back out of the coffee table and we'll start from there, because those results we got before, they're dubious. Back shortly. Okay, back to 41 kilograms of bricks. Let's take another reading. Hopefully it's going to be right this time. Okay, here we go. 336. I'll go with that. Jeez. Okay. So 41, 336. So that gives us 5. God's sake. Okay, 60 kgs going in. Jeez, I wasn't really thinking that the old Ryobi measuring tool was going to cause any problems. It's been really good up to now. Need to get to 60, 52. Just spin it around, put some on this side. Crash. $60, 61.5. $337. That'll work. Right, so we'll knock one of those off. 337, and that takes us up to 6 millimeters. Still quite worrying though, isn't it? At 61 kilograms. Okay, 20 more kgs. 78. That should be 80. There we go. 80 kgs. Right. 337. Wonderful. Hasn't changed. Okay, 80 kgs straight. And we're at 337 still. So that's 6 millimeters. Oh, things are looking up. We're on 96, 2 more bricks. 100.5 in fact. Okay, see what we get. 338. Right, let's get that written down. 101 kilograms it's showing on the scale now. And we've got 338 millimeters. That gives us 7 millimeters of deflection. Geez, we're over halfway. Still got 150 kgs to go. And a bit, because we're going to put the extra bricks on as well, so it's comparable to yesterday's. Tons of rain today. All day long it's been raining. Started in the early hours, just kept on going. So all the motorbikes that are outside are all soaking wet now. 108.5. It's not often you get to do this kind of testing, is it? It's pretty cool. 117. One more brick. 121. Brilliant. 338 was the last reading. Still on the screen. 339. Golly. So 121.5 on the sorry. 121.5 on the screen, on the crane scales, and we're up to 339. Jeez. Right. 20 more kgs. You hear any creaks? Jeez. So we're going for 140 kgs now. One more, I'd say. 141.5. Okay, we're starting to get some weight on there now. Jeez! 340 millimeters. It's not looking good. Right. 141.5, 340. That gives us 9 millimeters. We've only got 4 more millimeters of deflection. And it's worse than a flat beam. Damn. 144. We're going to get a brick in there. Yes, we are. Right, 160s are. That's the stop point. Somebody's doing some planing outside, aren't they? 160, bang on. Holy moly, 341. Right, so 160 straight, 341, 10 millimeters of deflection. I'm not impressed. Some more. So we're going to aim for 180 this time. Ah, the broken brick. We don't want that. One more. Okay, 180.5. Phew! That'll do me. Okay, 180.5, still at 341, 10 millimeters. We got 3 millimeters more, and we've equaled yesterday's deflection. Well, the good news is we're running out of bricks. I like that. Okay, spin it around a bit. It's pretty cool how it spins around so easy. So we've got to make an excellent coffee table. Wife doesn't know yet. She probably won't even allow it in the lounge, but it's definitely been load tested. Right, so we're going to stop at 200 kg, that's a fifth of a metric ton. One more. $201 kilograms. Okay. Oh, it still hasn't moved. Brilliant. Right, so I'm quite anxious for this one actually because I want it to work. So 201. We're still at 341. Still 10 millimeters of deflection. Right, we're getting close, people. Place your bets. Right, 220 coming up. There's a little jumpy spider thing on there. Right. $220. Not far away. Never moved so many bricks in my life. One more. 221.5 kilograms. Okay. This is going to be the deciding one, isn't it, I think? Hang on, let's bring you up a little bit. Not quite as much as that. Okay. There we go. Here we go. 342. God, it's going to be close. Okay, we're on 221.5. And it's 342, which is 11 millimeters of deflection. Right, more bricks. So we've now exceeded my estimation of maximum load, which was 217.5 kilograms of bricks, plus all the other bits and pieces. Okay, let's spin it around again. So I think we're just going to put the rest of the bricks in now. see where we end up. It's not going to fit. Right. Not quite. I think we got to about 1/4 of a ton, didn't we, yesterday? Day before yesterday. God, the days just blur. Okay. Well, there's your 240. 4 more bricks to go. Let's just chuck them in. Half bricks. We broke 2 bricks yesterday. Oh, look at that, bang on. 250 kilograms. Right, let's measure that deflection. So what do you reckon it's going to be? Is it going to be the same amount of deflection as the horizontal beam? Is it going to have more? Or is it going to have less? And the horizontal beam had 13 millimeters of deflection when it had 1/4 of a metric ton hanging from it. Plus the weight of the basket, don't forget, which is another 32.5, and a couple of chains. And the crane scale. It's not light. Anyway, let's find out. Here we go. Three, 4, 3. Jeez. Okay, so 250 kilograms. We had 3, 4, 3, which gives us 12 millimeters of deflection. We're 1 millimeter of deflection better off. Oh, give up. Right, well, the test is done, and it's taken me a lot of effort to get this rig set up today and finish the welding. But just to quickly recap, if you've not seen the first video, we used a horizontal girder, exactly the same girders actually before I modify them. We're staying with the joint in the middle and everything. And these are the results that we got. There you go, look. And it carried on. So that one there goes up to 181 kilograms of weight in the coffee table. And it carries on the back. And we ended up with 13 millimeters of deflection with, again, your 1/4 of a ton, 1/4 of a metric ton load, plus the basket. And, oh, God knows what that is. Okay, and then today's with the arched beam. These are the results that we got. Just to quickly recap, sorry about the messing around in the middle, technical problem, and that's it. So yeah, 250 kilograms. We ended up with 12 millimeters of deflection. So 1 millimeter. Now this tool, it's really, really good. But can you see that? Oh, you can, look at that. That's pretty cool, isn't it? So how far away is the camera? Oh, we didn't like that. It really isn't 1.15 meters. Error, that's more like it. Okay. So yes, it is a really good tool, but I did find that when you've got it on a flat beam, we found a piece of wood for you here. Here's a bit of wood. It doesn't actually sit, you can see that or not, it doesn't actually sit dead vertical. It sits at a slight angle, which is a real pain because it means that you can wobble around and you tend to get a bit of a discrepancy in the readings. I'm going to get my square for you. Hang on, I've been using that. Now, obviously, it's meant really for handheld work, but crap, come back. Right, there's your square, and here is the tool. And I think, oh, there we are, look. I think you'll be able to see from the camera that it doesn't sit dead straight, so you've got to compensate and try and get it straight, but then, of course, it wobbles around a bit. There's your problem, and Ryobi, why have you done that? It should have a flat base to it. That is just wrong. Okay, not a square. Jesus, okay. Right, well, hopefully you enjoyed the video. I have now got to disassemble all of this, but tomorrow I can start to put it up in the garage. And there's going to be 4 of these. If you've not seen the previous videos about the design and stuff, there's going to be 4 of these going from one side of the garage to the other. One of them's just behind me, and there'll be one just in front of me behind the camera, and then 2 more further down. And you're saying, well, Andy, why on earth are you doing this? Are you trying to earthquake-proof your workshop? Zombie-proof it? What's going on? Well, what I'm going to do, is remove this center wall down here. It's a concrete wall because these 2 garages, they were built at different times. This is a single garage, and it's got a 3-foot high concrete wall either side on this garage, and the other garage is more of a lean-to be honest. So for me to take away that retaining wall, and that wall is currently holding the roof up, I have to put some other structure in place to, well, provide lift. So these 4 beams, when they're all finished, will go across the workshop together with some other bits and pieces of steel work. There's an awful lot to do. But once they're all in place, then I'll be able to remove that wall and we'll have a nice open plan workshop, which will be much better for filming. That's the plan. Okay, well, today is rolling on. Still got to get this pulled apart. If you enjoyed the video, why not click on the subscribe button? I think it's over there, I keep forgetting. You can subscribe, and then our friends at YouTube will send... Let's do that again, eh? That was terrible. So, if you enjoyed the video, why not click on the subscribe button? You'll see a little gear icon turn up. Click on the gear icon, and then you can tick the box and turn on notifications. And same as ringing the bell on your smart device. And our friends down at YouTube will send you an email as and when I upload any new videos. You'll also find me on Facebook. Oh, shut up. You'll find me on Facebook, Instagram, and Twitter. Google Plus has long gone, so if you're watching any of my old videos, you won't find me on there anymore. It doesn't exist. Sorry. And there's also a Patreon page. You can drop onto that. There's a link at the main home page of the Andy Mechanic YouTube channel. Click on the Patreon icon. I'll put a link in the description below as well. And you can read all about the history of the channel, how it came to be, where it's going, up and coming projects, information and background of all the different tool girls that come on the channel, together with some photos, and I think there's a couple of videos on there now that you can download as well. Great fun, isn't it? For all those patrons out there that are currently and have supported the Andy Mechanic channel, the donations that you've sent through are very, very much appreciated. And it's without those donations, I would not be able to do big projects like this. This was way above my normal budget, to be perfectly honest. I've purchased about just under half of the steel. I've got enough steel work at the moment to do 2 of the beams. We'll get those done, installed, and then I can take a bit of a break, and then I'll do the other 2, because there's a lot of work involved with these, and I've got other stuff going on as well, and I still want to make you other videos at the same time, so, you know, it's a bit of a balance, isn't it? But these, half of the steel work was just shy of 2,000 New Zealand dollars. Then there's the bolts, MIG, wire, gas, paint, you name it. It soon stacks up. I've probably spent about 3 grand just doing one half of the garage. Don't tell the wife, she will go mental. Okay, crew, well, until next time, cheers, over and out. Morning, crew. A bit of bonus footage for you for the end of this video. Simon Roll commented the other day that some of the deflection that we're measuring on that beam isn't actually beam deflection at all. It could possibly be that the oil drums at each end of the rig are compressing down slightly under all the weight. Now remember, we've got the weight of the beam, which is nearly 100 kgs. We've got the weight of the coffee table at 32.5, and then we've got another 250 kilograms of bricks in the coffee table. So we can divide that total by 2, and that's the amount of weight on the drum. Plus, yesterday we had a couple of very large steel plates on top of each drum to spread the load across the top of the drum. So we better include that as well. So we'll put the steel plate on top of the drum, and then we'll stack a heap of bricks up on top of that, matching what we believe to be half the total weight, and each brick weighs about 2 kg, so we can use that. So what we'll do first of all is we're going to measure the height of the drum just using a thin piece of steel going across. We'll take 4 measurements, and we'll take the average of those 4 as a starting point, as a datum, and then we'll load all the bricks on. I'll do all that off camera, put all the bricks on, and then we'll measure it again under full load, and just see if that distance has reduced slightly. If it has, then we can deduct that from the readings that we got when measuring the beam deflection. And that would apply to both beams, the flat beam and the arched beam, which is the one that we're using obviously for the workshop. Okay, well, let's get some measurements taken. Here we go. Okay, first reading is 888 millimeters. Right, 888. Right, measurement 2 coming up. Oh, pretty close. What do we get? 887. Pretty good. Right, 2 more to go. Woohoo. Okay, another one at 888. 1 more to go. 887. So pretty consistent readings. It's pretty good. Okay, well the average of that is going to be 887.5. I can work that one out. Okay, now I'm going to have to work out how many bricks to put on. Okay, working around the camera, so forgive me. Right, so the beam itself on the second test weighed 99 kilograms, and that's the one that we're really interested in, isn't it? And then we've also got the weight of the coffee table, which was 32.5 kilograms. And we also had the weight of the crane scale, not much I know, and chains. I don't know what that is, I need to weigh it. Okay, let's find out. It feels, I don't know, not too heavy. Hi, good morning, right. Crane scale, what chains, crane scale, what have we got? 2.7 kilograms, that'll work. Easy, save the batteries, right. Okay, 2.7 kilograms. So we need to add all of that up. And in my head, at this time in the morning, it's not going to happen. 99 plus 32.5 plus 2.7. Okay, so we had 134 there, 0.2. And then we also had, obviously, the bricks, which was 250 kilograms. Sorry, my writing's terrible, I'm doing it at an angle. So, plus 250 gave us a grand total of 384.2. Now, there is also the weight of the big steel plate that I put on top of the drum, but we're going to reuse that, so I don't need to include that in the calculations. It probably weighs about 15-20 kgs. It's pretty heavy. Okay, well, we need to divide that by 2 to give us the number of, or the load on that one drum. So each drum had approximately 192.1 kilograms plus the plate. So over 200 kgs on each drum. Right, so we're going to need to divide that by 2. And we need 96 bricks. Oh, God. 96 bricks. Fantastic. Okay, I'll get it loaded up. Okay, I brought in 96 bricks. And I've put the plate, and the plate is flat. It's actually the base for a bicycle stand, a Park Tools bike stand. Pretty good bit of plate. That's why it's not being cut up and used for anything else. Okay, I'll put you on fast forward. 96 bricks. Better do some measurements now, eh? Oh. Interesting. Loaded. We got 887 as the first reading. And the second reading, 888. Oh, I couldn't have planned this any better. Third reading, 887. Jeez. It's all in the last one. And the final result is in 887. There's not much in it, is there? Okay, so 887 times 3 plus 888. Oh, that's wrong. 887 times 3 plus 888. That was right, divided by 4 gives us the average. 887.25. Geez, well that proves that then. So, thanks to Simon Roll back in the UK for sending through his comment. We have proved that there was a compression of the oil drum of 0.25 of a millimetre. I suppose it all adds up. That means that our compression of the, or the deflection of the main beam that's going to go up in the workshop wasn't actually 12 millimetres, it was 11.75. Proved. Okay, well, I really must crack on with the workshop now. I've got a ton of work to go, and this is the start of day 5 of 10. And by the end of day 10, I've got to have at least, well, I've got to have the 2 beams up in the workshop, and part of the wall knocked down, and all the benches moved back. That's the plan. Is it going to happen? I don't know. Okay, crew, see you around. Over and out. And we get the thing up again. Oh. Yes.